Welcome to the course Algorithmic Design. So let's go to the website to get some data. So the sparse matrix website. Let's go there and let's try to get some. Okay, I have to unfortunately still transfer the code. Okay, so I have some matrices here, but let's go on their website. It's here, and so I'll show you how to read the data from it into Python, into Rhino. Actually, in the meantime, open my Rhino and let's go here. Okay, so this is the link. I'll actually put it now, just also down in the in the chat. Here it is in the chat now. Sparse.tamu.edu. Okay, so it's a sparse matrix collection. It's a bit old-fashioned website, but basically, it has like, what is it? Collection of matrices. I mean, he's 2000 something, but this is that 20. Okay, so it has 2,900 different sparse matrices in different formats, and let's sort them first in according to row size. Because then we can, for example, go a bit forward and we can try to find some that are maybe around 100 by 100. And actually see there's, maybe like, which one did I use? Maybe this one here. So this one is kind of 100 by 100, so it's maybe something manageable by us. And you have information here about every matrix, some kind of stuff. So what is it's some kind of structural problem. And the cool thing here on the right, you can actually see how the adjacency matrix looks like. And it's not only the adjacency matrix, so the values that are inside, the values that you have of these coefficients they're encoded here as a color. Or so it's not just black and white, but there's a kind of color that encodes a little bit more information. And yeah, then kind of each of these. For each of these, there is a kind of a lattice representation, and yeah, you can load it. And I'll show you basically how to. I'll show you how to load it. Let's actually get some that I already know that work quite well from yesterday, and I'll just get a link from it. I think this one was cool, so I'll just get a link. I'll also maybe quickly send it to you in the chat. So maybe let's look at this one here. So I was looking at them a little bit yesterday. I tried to find a good one. Okay, so this one is called ARK-E2513, and oh no, actually it's not this one. There's another one that I wanted, but let me see. Actually, maybe this one here. So I just want to use a good one as a first example, because we will then also sort of build it at the same time. It's this one here. Yeah, I think this one is a bit better. Okay, so it's this one here, GRE115. So again, there's kind of a matrix here, and there's the guys already did a simulation for it. We'll try to just reconstruct it. Okay. You can download the matrix here on the bottom. So it's basically just some kind of data format. And I want to show you basically how you can kind of load it into Python. So you can do MATLAB. MATLAB, you cannot really read directly because it's a proprietary format. This one works, and this, we will use this from kind of matrix market. So if you just download it, again, maybe you don't need to do it depending on what kind of zipper you have, or WinZip or something. So you get this kind of a compressed folder, and then the best thing to do is right click. So maybe you have WinZip, or I use this, I forgot, 7-zip, and just say extract here. Then you get another one. You can do this also from multiple files at the same time. So another one, again, extract that one as well, and then you get the folder. So that's a bit. Okay, and then in the folder, there is MTX file. This is basically a text file. And I just want to show you, if you just, well, you can just open a notepad, and so it's MTX, but it's basically you can read it as a text file, or so. Actually, not here. That was the one. Yeah, I have now in 2 folders. Okay, so if you just open, if you drag and drop it into Notepad, this is how it looks like. Or so it says there's some information at the beginning. Okay, blah blah. There's a name. There's a link here. Authors or editors of the matrix. Unsymmetric matrix, voila, 1981. Okay, and basically the data is here. Or so basically at the beginning we have the size of the matrix, so it says 115 times 115, and there is 421 non-singular values. That means 421 values are actually defined. All the other ones are 0. And basically here we have only these 421, because somehow this format is that you only show the values that are in the matrix. So kind of here, or only these dots are kind of displayed, and yeah, only the dots are kind of displayed. And this is actually not a symmetric matrix, so it's a bit, but it's for us, for our purposes, we'll just treat it as if it's symmetric. So we'll basically just work as if you kind of take the values from here, copy them on this side, and the other way around. So we will just treat it as a symmetric matrix in order to get these adjacencies. And yeah, only these dots are basically shown in the file, because otherwise the file would of course be a lot bigger and it would contain a lot of zeros. This is also good for us because we can parse it then quickly. Here we basically, these are the coordinates of the node. Says node number 1 is connected to, well, node number 1 as well, but for example, you know, node 14 is connected to node 3, and or on the column, I think it's the column 14, row 3, there's a value of this much. And in computer science, maybe you already noticed, often when you have 0 point something, then this is just basically written as a not, so kind of a point something. Or so we just show the decimal part, we don't put a 0 at the very beginning. So if there's a decimal point, you just assume that there's a 0 at the beginning. This was from the days when memory in a computer was very limited, so it was not necessary to show also 0 and the dot. Yeah, so so here we have kind of always dot, and then okay, so basically these are our you know, which node is connected to which node, and then there's this kind of value, but we'll just treat this as if we don't really care about this second number here. But let's say we want to load this into Python. I'll show you kind of how to do it. And you can then use this for many other types of files. So basically this information we need to convert it into numbers, because these are not really numbers. These are kind of written as numbers, but if you load it in Python, these will be strings, meaning this will be kind of letters. So we have to, you know, and we have to kind of be able to split them. So I'll show you basically how to do that. Okay, so I hope you can see my Rhino. Just adapt a little bit stuff here. Just remove the grid. Okay, actually in this case we don't even need Rhino. We just need the Python part. Okay, and okay, we just need the Python part, and I will just kind of create a new file, and I will what should I actually, for working in Python we don't even need to import anything. Let's just put, okay, I'll just write it, reading MTX file. Okay, so I'll just put it in here. I'll give you this code later, but this we can just do kind of from scratch. So something like read MTX file. This is how we're going to call the Python script. So okay, so how do you read the file? I'll actually use a little bit of a cheat sheet. So you can go online and say, for example, Python reading files. Okay. So there's like different ones, but this docs Python is usually the best one. And here they explain basically how to read the files from outside. We'll just copy paste some code from here. Maybe we'll use this one here. This is just from a syntax point of view, it's a little bit better. So we will say, you know, basically we could just say also just kind of open, and then we can write a file name here. But this is a bit better syntax in Python. You can say with open, and then this is the path, so file path as f, and then we are basically kind of reading in the data here. This is a bit better because when you open a file, basically you have to be sure also to close it properly, otherwise the file can get corrupted. So if you write it like this, then you're sure that the file will be kind of closed at the end of when you execute this file. But basically, just see. So I'm going to not load this file here, but one that I have in the folder. So it's here. So basically, my code is here. I have it's called here read mtx file, and then I have a folder, relative folder, which is called sparse matrices. And then here, the one that we kind of downloaded is this GRE115. Okay, so I have to kind of access this file. And that means I have to kind of access this relative code or relative path. And that means this file path, I can just say here, you know, file path is, I just put a small string in. And this is going to be basically, yeah, I can just put it directly in if I want, but I'm just going to write it a bit outside. Okay. So relative path is folder sparse matrices. Then Windows have to do it like this, double slash GRE115, and then the name of the file is this GRE115.mtx. Okay, so that's my file path. That's relative to the Python file that we have. Or so if this is the Python file, it's then basically reading. Okay, first folder is sparse matrices, goes in, then GRE115. And then this is the mtx file. So that's the relative path. And yeah, I can just kind of run this and nothing happens. Potentially it's kind of done correctly. I can just say, for example, print read data. So one error that you can get here is, for example, you know, it would tell you file doesn't exist or couldn't find the file or something like that. Of course, if this name here and path is wrong, Python will not be able to find it. Okay, and here it is. Basically, when we use this read, the file is already kind of read fully in. Or so we basically get the whole string. So everything that's in the file, it is already here. Or so it's just kind of read data. We can use something else, for example, data lines. It's f dot read lines. So read lines is another. Read lines is another function. So this is just kind of, I think, reads the whole file, and here reads the file and outputs individual text lines, yeah, file lines or something like that, file lines. Okay, so this is a text file and it has lines. These are kind of lines, and we can read them and put them in a list, which is a bit more convenient for us because we don't really care about the text file. We care about kind of, you know, what is in each line. Okay, so if I run this, let me just see. I maybe did a small mistake. Okay, yeah, yeah. Somehow, for some reason I cannot really get them. I guess I have to maybe use a bit different. Just see data lines. Open. Yeah, it's somehow I cannot do it at the same time, which is weird. Okay, so I have to comment the first one. Okay, so I can do instead of read, I can do read lines, and then I get them. I get basically a huge, like a Python list, where now every line of the file is saved here, and you can see that at the end of each line there's this \n. This is basically a new line symbol. So in a text, if I would open this text here, in this text editor, you know, there's needs to be something in the text that is telling the Python, or that is telling the, you know, notepad to press enter and to go into a second line. Or so this is this enter is so-called the new line symbol, and basically we reveal it by kind of reading the file correctly here. It's kind of \n. This is basically, it's like an enter, or so that's at the end of each line here. And again, if you open it in a text file in a notepad or Word, we don't really see it because that's you know, that's information that's just the formatting information. But in the computer memory, or in a way, this file is just like one long line. So you can imagine, you know, this part is just glued to the next line, and in between there is kind of \n. Also, that's a little bit the insight is that the file exists in memory in one way, and then when it's displayed to you in Notepad or Word, it's some things are omitted, some things are just removed because the formatting is done so that it's easier to read. But in the memory, there's this \n that exists, and that's important for us because we need to remove it. Or again, there's probably an easier way to read in this file. So you kind of online, you can find many different ways of reading files, and sometimes you don't need to worry about details. But here we are doing it a little bit manually because I want to show you how you can do it when there's, you know, no other recourse. So kind of step by step. Okay, so we have these lines, so we can do something like, you know, well, now we can have a loop. You can say for, you know, data line in data lines, or so we can now go through each line and we can print each line, or so we kind of print the individual line. So it's the same thing, except we do it kind of one by one. Okay, this takes a bit long, but here it is, kind of every line is printed individually. Or so now we have kind of the data line is here, and maybe because we already know that there's at the beginning here something that we don't need, or so there's this, you know, we can say something like, you know, relevant. You can say, for example, well, there are some relevant lines, or there are data lines and there are relevant lines. So the ones that we actually need. So what we want to do, we want to slice this list. So by accident, I know that I think this like first 14 lines or something like that is this. We at the beginning we don't really need this some information. So we can just slice this list, and we do this with list slicing. I think I showed it way early in the course, how you slice a list. So if this is a list, you can write something like 14 like this. This means relevant lines is now a list. It's a sub list of this data lines list, and it starts from index 14 and gives you basically everything after that. Or so this column means kind of everything after. So if you run this, we should get, we basically just got kind of the later portion. Or so we start with 1, 1, and the whole first part of the first 14 lines basically are not here. That's some information that we don't need. So those are the relevant ones. Okay, so we kind of filter them out, we cut them out. Okay, now the next thing, what we will do, so each of these data lines is basically a small string. It's this is a small string. Also, now I want to extract each of these basically out, or each of these numbers out. So we can do something like, if this is a string, then there's kind of inbuilt sort of string operator in Python called split. Split. And So basically I can split the string. I can split the string and I can use, I have to tell what is the delimiter or what is the element that is kind of splitting. And it has to be something inside this string here. Or so if I zoom in, what is actually separating my values here is a space. Or so there's a number, then there's a space, there's another number, there's again space. Okay. If you use, for example, CSV, so data, then this delimiter might be comma or semicolon or something like that. But here it is space. Or so basically I would say split and then just put like a small space here. So it's a kind of a string that is just small empty string, or has a space inside. So it's a bit kind of, you cannot see it, but this is a space inside. And then these are, this was a data line, and then these are some kind of, data elements or something like that, or I can just call them elements. Okay. So this is now going to be another list which will contain, 1, 2, 3. It will contain these individual elements inside. And then maybe I'm not printing this data line, but I'm printing these elements. Let's see how they look like. Okay, so I'm kind of splitting further and further, or so I'm kind of going further to what I need. Just run it. Okay, now it is, so now I get another list where each element is, well, each element is basically, one number. But again, the issue here is that these were not really numbers. So the format of these characters that you see here is a string character, or meaning they're a string. So they look like numbers, but they are kind of, in Python recognizes them basically as letters. The same thing for the kind of the float values here at the end. There's also this kind of a weird, this kind of a \n or new line character. So we have to format this further, but now we are almost there. Or so we can say something like, well, there is some kind of I value, which is, elements. It's the first one, or first element inside these elements is my maybe I value. Let's call it I. Then there's J, and then there's at the end, we'll just call it V or something like that. Okay, so we have elements 0, elements 1, elements 2. Okay, but the first one is a string. We want it to be an integer. So we'll just use, int. We'll convert it, whatever this, well, we know that this element's 0. So the first one is a string, and we will convert it into int. So into an integer. We'll do the same thing. So this is a small Python function which just converts the whatever is inside here into an integer. And here we have to do, we'll do the same thing, but we'll convert it into a float, or because we have a decimal value, we'll convert it into a float. And this will not really work just because for the last one, we cannot really convert this into a float because we have this small kind of thing here, or so this new line character. So we need to basically somehow remove it. And again, there's different ways to remove it. I'll just check quickly how I did it here. There's a small trick that I will try to use. I think I can use this. So in the code that I will give you later, I did this a little bit differently, but I used basically all the same elements. Okay. So if I think this should be fine. So we accessed the third element, index 2, third element from elements list, and we filtered the last character out. So we kind of we take everything except the last element, and this is basically it looks like 2 characters, but it's basically 1 character. It's the so-called new line character. So we kind of take it out from the back. Okay, so now I will actually just print out this I, J, and V, and let's see what we get now. So again, this might be. So now we have the original one and reload. Okay, so this is basically, this is now correct. Or so it's a bit hard to see, but at the beginning we had you know, 1, 1, and then this weird number here, and then you convert it into integer 1 here, and then this is a float, or so this last value is just converted into a float value, or so it's basically this number here, and then in Python here the floats are displayed with the 0 at the beginning, and we just, with this small syntax here, we just remove the new line character. If you remove this, I think we will get an error. Or actually, okay, in a funny way, we didn't get an error. I think it's because, okay, I think it's because this new line character is just treated like a little bit special in Python. So if this parser kind of encounters it, it will just neglect it. So it will just say, okay, you're not a number, you're a new line, and we don't do anything with you. Okay, so we actually, this small fact that I had here, we don't even need to include it. Okay, so we basically convert these into numbers, and that's it. So that's basically it. So now we have our data. We basically extracted the data from the file. Also, we have the I, J, and we as kind of numbers, and we can use this. So we can basically use this in our code now. So yeah, kind of not to kind of overdo this, but maybe I can just do kind of a very quick test. So just to show you, you can do something like, you know, import, you know, rhinoscriptsyntax as rs, and then you can do also import rhino.geometry as rg, and yeah, kind of maybe you want to sort of, we want to just say something like, let me, there are these relevant lines here. We can call it, how do you call it? Let's call it, yeah, let's call it something like, call it maybe something like, I'll just call it just data. Or so we have a kind of a data list, and then this, instead of sort of printing this, we can just put this value into this data list. Or so there's data, it's like extract the data, append, and then here I can call it here. This is called kind of extracted data. We'll package it maybe into a another small list where we have I, J, and V. And then we'll just use this extracted data and just put it in here. This should actually work. We're not printing anything. Okay. And yeah, now I can just say something like, okay, for, you know, data element in data, we can do something like, you know, you can define a point, which is, you know, at the coordinates rg dot, so point 3D, and maybe do it flat, or so we kind of look from the top, and here we say there's data element, you know, the first one will be the x coordinate, and then the second one will be the y coordinate. And then there's, well, the z is in this case 0 because we're just going to do like a flat thing. And yeah, rs dot add point, and we can just add this point. So now for every data element, we will just add a point. So we'll kind of basically draw our matrix here. I think it should work. Yeah, we have a problem with the should. Okay, from the top. Let me just do it again. At the beginning, we can do this rs dot enable redraw as false. This is also at the beginning, reading mtx files. Let's kind of just comment on the top. Okay, and basically this will just draw our kind of matrix. You can see now this one, we just sort of drew the matrix as sort of points. And that's a little bit, if I go here online and try to find it, is, well, I guess it's a bit flipped because I maybe flipped some values. Yeah, I guess I have to maybe flip X and Y or something like that. But this matrix is now basically, it's the same matrix as here. Okay, but that's basically just extracting the values. And that's just the first step. So this I can save. And let's try to do the proper thing also. Let's try to kind of simulate the lattice, or so that's kind of the goal. And for that, so I will give you this file maybe later. So I wrote let's load lattice. Okay. I kind of rewrote a little bit this the network class. And again, I will give it to you. So basically we can, I don't call it a network anymore. I call it a lattice. So this was what we used for dynamic relaxation. So instead of having a network, we have a lattice. It's very similar. So you can see, for example, there's this update. It's very similar. There's calculate neighbors. Then there's calculate displacement. There's draw me. But we have some extra methods like calculate node repulsion. So calculate neighbors is also done a little bit differently. We have also calculating the centroid of the lattice, because the lattice is not really fixed anywhere. So we calculate the centroid of all the points, and then we glue that centroid onto the origin, which makes the lattice kind of being fixed in the Rhino canvas. So it doesn't move relative to that centroid. Yeah, and then kind of rest of it is sort of pretty similar, I would say. There's this, we calculate the node repulsion, displacement the same way, and then drawing is done also very similar. And then I will also show you there's an animate method, so we can kind of we can sort of create automatic. We can export automatic images and create an animation. I'll just show you kind of quickly how to do that as well. Okay, so there's this lattice module, and I just want to show you how it looks like when we are running it. So we load in rhinoscriptsyntax, run a geometry, and then the system drawing actually we don't need for this one. Okay, and actually we don't even need the random here. So we just basically from this lattice module, we import lattice, or there's also at the end, there's also the node, or the node is the same as before. I added here something, but I removed it later. So the node class is the same. And we are here in this file, we are only using the lattice. Or so we kind of, no, actually, I just realized, yes, we don't need the random because we are defining a seed, or so it's, we want, at the beginning, all the points start randomly. So this we want to fix at the beginning. This is just clearing out everything that is in the default layer. And similar like before, we define a stiffness of the lattice. So this is how much this lattice will sort of move. So how fast the simulation is. Of course, we want to have it as fast as possible, but then the number cannot be too big because we get sometimes weird things can happen. So we need to find a balance for this number. Then there's the matrix path, or so this is again the relative path. And I will just load in this ARK-E2513. So we are loading it in here. Then we define, we create a lattice object, which is defined as a lattice class. We just feed in a stiffness inside. And then we create, there's a method called from matrix, or so this what we put in outside is the matrix. And there's a method that kind of creates, so defines the adjacencies of this lattice from this matrix. So basically we just give it a path to this MTX file. And that's it. And then we have basically the update, same as before. There's a kind of center And we can also say here if you want to draw it or not. And yeah, so actually let me show you what happens if I do it real time. So I can do, so I would say drawing through. So I'm drawing every iteration, but then maybe we don't do 100 iterations, maybe do just 100 iterations. And you'll see how it looks like. So we can kind of see the simulations are happening. I think this should work. Okay, we're a bit too far away. And let's actually do it again. So it is very similar to, again, how this dynamic relaxation works. Actually, let's do 500 iterations. But again, we are not, we are also, so the elements are, so the nodes are not only attracting each other, but also repulsing. Or so there's a, they're all actually trying to be 1 unit away from each other. So that's kind of the so-called rest length. You can see here the animation basically stopped. Nothing is really moving anymore after maybe 200 iterations is already enough. And it says here the matrix 115 times 115 has 421 non-zero entries and 115 nodes, or so 115 points. And that was, what was that, 400 something, 412 edges. So if I select these lines, here select line, I should get, oh, actually 200 something. Yeah, there was something was doubled. We purify that. Okay, so this is basically the lattice that we get. And if you compare it with the one online, it's not exactly the same, but I think it's quite similar. I think it's, I think we would need to modify the parameters a little bit to get basically something similar to what they got. And I'm not sure actually what the difference is here. We'd have to check exactly how they got it, but this was sort of just a quick, sort of a quick try that I did. And let me just do it one more time. So this is sort of, you can see the unfolding, and we'll try to do an animation of that. If you want to do things a bit faster, you can just, you can do it faster as well by saying here draw. You can put it here to false. And then it will not, you will not draw at every iteration, but at the end you have to actually draw the result. So we have this other function here, just draws the final result. And then you can see that if you just run it, you will get it much faster. Okay, so if you don't want to wait, you can kind of do it like that, 500, and you should get kind of the final result. So that's just a faster way of doing it. Okay, and let me actually see. Let me actually save this lines. So here you can kind of save them. Select line, change layer, and you can go to this gray 115. Let's change the color to something that's a bit nicer, maybe magenta. These ones we can delete. Okay, so now, now if I run the simulation, for example, again, you can see a little bit, because we fixed them. Let's run the simulation again. But now the final iteration is already in a separate layer, so that one will not be deleted. So if I just run it, you kind of now see the, you know, the simulation is. So we will get exactly the same result. Yeah, we will get kind of exactly the same result as before. A bit less because we had before, I think, 500 iterations. And yeah, I want to show you what happens if you remove this random seed. So if you run the simulation now, we will get kind of more or less the same result, but it'll be at a bit different place, or because the initial conditions, so initial distribution of points will be different, or so kind of the lattice is the same, but it is a bit rotated. It might also have a bit of a different size. So that's why we fixed the seed of the random engine at the beginning, because we wanted to we want sort of always to get kind of exactly the same result. If you remove the seed, then they always start a little bit different. So the simulation will always give us a little bit different result. At least it'll be rotated differently, even though the lattice itself might actually be quite similar. Let me see. Actually, here it even looks, it's a bit hard to see if it's, turn it off. Yeah, it's a bit hard to see if it's exactly the same, but basically it is a bit of a different embedding of the same graph. Or so that's the key. So here we can fix the seed. Of course, here inside you can have any value you want, any string you want to fix that value. And yeah, just one final thing. So I go back to the old seed, and now the two iterations should exactly overlap. So it's random, but it's kind of always the same random that we get. Okay, and I'm just delete these ones, and just to show you, before we do that animation, I just want to show you again how you can kind of play with this. You can sort of make it physical or add geometry to it. So there are different ways to do it. Just see the distance here from here to here. Okay, so you just select all the lines. You can go here, and this is Rhino 7. So in Rhino 7, you can use these sub-D tools. Here it's called multi-pipe, and the pipe radius maybe 0.1. Enter, enter, enter. Okay, and you basically get this, or maybe to rendered view, get this kind of a sort of a lattice. Now this lattice is not really that beautiful, to be honest, but I'll show you another way where you can modify a little bit how the lattice looks like. So if you're interested, like this is, for example, you can 3D print it. If you turn it into a mesh, save it as STL, you can go on, in Vera, the 3D printing lab, and you can actually print this. But of course, then supports need to be somehow created. So let me actually select the sub-D, and I'll show you another way of doing this. So we can go into Grasshopper. So where you have a little bit more freedom in how you model this lattice. And yeah, I apologize for not giving you now the code, but as soon as this finishes, I will give you the code so you can also play around with it. So in Grasshopper, we can add, there's under surfaces, sub-D, there's a multi-pipe component. So that's again in the new, in Rhino 7. And here we can get the curves. So maybe here we can, we can load in curves, right click, set multiple curves. The curves go in, and we already get some kind of results. The node size is the thickness setting. So we can do something like slider that goes to 10, slider type, floating points. So we can go to node size. And then now you have to just kind of reduce it. So it's basically, it's the same function, it's just we have a bit more freedom. Go down, 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 down. And yeah, maybe we put it to 0.1. Maybe 0.5. Okay. So, maybe 0.3. Something like that. And you can see that results are a little bit different because we can fine tune what happens here at the intersections. There's this end offset Stroud size. So I'll show you that. Slider type, floating point. Also a bit longer, maybe like this. I think Stroud size, it's the percentage, I think. So if you go a bit lower, you see that it'll become kind of thinner and thinner and thinner. You can actually go the other way around. Values, maybe you can go maxes, maybe let's put 10. So you can go below 0, and you can go kind of above. And if you put Stroud size kind of bigger, it becomes kind of blown up. You can see here, it becomes sort of like like some kind of muscles. Okay, or you can go kind of lower. And maybe we put here 0.5, and here we put also 0.5. And there are some other parameters here that you can change, like yeah, end offset and so on. So a few other things, and then we can just bake this, or let's bake it, and we get the same thing. Just turn this off, turn this off. It looks a little bit better. I mean, better. It's a little bit, I think, nicer than the one that we had before, because we have a bit more freedom in how we defined, yeah, the kind of sizes of lattices and so on. Oh, it's a bit rotated weirdly, but okay. Okay, and yeah, then as you know, you can do screenshots of this. So for example, we can go here, and I can take actually a screenshot of this, like directly from Rhino, and yes. Okay, so zoom selected. There is something called view capture to file. So it's a view capture to file, and then I can set the kind of the resolution and so on. Say okay, and maybe algorithmic design, visuals, and JPEG or PNG. Hard to say, PNG. Okay, and here we can call it view capture, something like, let's call it Lattice. I think this is already the name is the date today, and this is the time or something like that. Lattice. Okay, visuals, save. Okay, so it'll be exported, and if I go here under visuals, and it should be somewhere here. Here it is. Okay, so now this is just a PNG file, and again we can set the resolution a bit higher if you want a bit nicer preview. So this is how you can get the images out, and I want to show you still how to do the animation. Okay, so let's go back here, read matrix. So again, we have the kind of the outcome is here. But let's say we want to animate this, or so let me actually find a good view. Maybe it's a bit hard to rotate. Okay, something like this looks like a good view to me. Yes, so zoom selected. Okay, we're somewhere here, and yeah, let's actually run the simulation again. True, maybe just 300 iterations. So let's say I want to animate this. I want to take basically all these frames. I think 300 looks okay to me. Maybe even less. Let me see. So maybe I just want to do like a very quick. Oh, I'll actually, yeah. Let's do it finer. So we can do yeah, like 300 here, but reduce the stiffness a little bit, because this will make the simulation run a little bit slower, so we get a bit higher frame rate. And now we basically want to interpolate, like each of these frames, we want to just take what we did before with view capture to file. We just want to basically run this function separately. Or so we can do that by, there's this, I have written kind of a method here, which is called animate frames 300. And then these are height and the width. These are supposed to be the parameters for the size of the image, but somehow it didn't really work. I don't know why, to be honest. Something was a bit off. And here under Lattice module, you can see the kind of the animation. You can see a little bit kind of how this animation code works. It basically does everything the same as when we run the update method, except that runs the update, and then it kind of runs also this capture to file. I actually have to check this maybe better. You also probably have to change the path. Of course, this goes into my here under animation. So animation name, and then epoch is just the time and some other parameters here. So this will basically save everything into one folder. Let me actually check first where that folder is. So the folder is Lattice grammars animation. So we have to make sure to find this folder. Lattice grammars animation. Okay, so it will save everything here, and we can then grab it from there. So reset. This I can remove, and 300. Maybe everything should be okay. So I can delete. Okay, so hopefully my computer will not crash while I'm doing this, and my connection will still stay on.
While it's running, one question.
Sure.
Would it be possible to do this multi-pipe thing in Python, or is it something you have to do in
that is a good question. So I actually tried to do it in Python and I didn't succeed. It must be possible. I just don't know yet how to do it. I was actually looking into it, to be honest. I didn't yet figure out how to do it, but yeah, somehow it should be possible. But yeah, I still haven't found the code, and where I played with it a little bit, it kind of didn't really work. So yeah, that's it. Hopefully, but I will invest a little bit more time into it. So if I find a solution, I'll be sure to kind of pass it on. Okay, I'm actually now running the simulation, and you can see here this might actually take long, to be honest. 300. So you can see here that every frame is now everything is slower, or so the kind of simulation is done, and then this view capture to file is run, and of course this takes some time. So I just realized that these 300 frames will probably take a bit longer than expected. And but yeah, basically they're all saved. You can see in the folder they're kind of should be coming in. Yeah, they're kind of all here, except I don't think I can really stop the execution. But frames are coming in here, and usually Rhino doesn't like if you do other stuff because then sometimes you can get kind of glitches in the images. So usually just kind of leave it to work. And yeah, then I will just show you quickly how to stitch that in Photoshop. It's kind of quite easy, and that's it. That's how you can kind of also do animations of your kind of code in the using Rhino. That's actually why I like using Rhino, because it's very versatile, you know. So it is a CAD drawing program, but you can, you know, code, you can draw through code, and then you can sort of do this automatic export of images, and you can kind of, in a way, make animations. And that's, I think, quite a powerful workflow. It's just a very powerful kind of a drawing program. That's why I like it a lot. Looks like it finished, so I'll just save this. Go under animation, here they are, and I'll just run the frames. Oh, they're actually, the first one is somehow very ugly. Something happened with the first one. There's some glitch, just delete it. Okay, so this is kind of then our first one, tuck, 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 tuck. And if I just run the images, you can see kind of how the simulation is developing. Of course, it's a bit slow. So let's do let's do another folder, which will be Gray Lattice for 115. So here under animation, I can say new folder, Gray Lattice, Gray 115. There should be around 300 of these. I put it inside. Okay, now there's a step that I have to do in between in order to load it properly in Photoshop. I need to do a bit of hacking. So I need to rename all of these. So I can use Bridge. So I don't know what you use if you need to rename a lot of files. I use Adobe Bridge, but I guess there's some shell commands. You can do it a bit easier. Okay, so we'll just rename all the files so that the numbers. So again, the frames are named. This is the timestamp. It's in epoch, so it's kind of I think it's milliseconds or something. So it's a kind of a unique timestamp for each frame, but this is not consecutive. So they're kind of they go from the smallest to the biggest one, but they're not consecutive. So we need to just adapt that a little bit. So if I go here, I'm in Adobe Bridge, go Lattice, I can select all the files. And I can go to Tools, Batch Rename. I'm going to batch rename all the ones, so I can kind of can go and just call it according to the name of the sparse matrix here. So they're all going to have this name in front, GRE115 underscore, and then we start with 1, and we need 3 digits, rename. So takes the time. So all the files, all the 300 frames will now be renamed. Should also update eventually. Perfect. Can close the bridge. We are here. So now they have consecutive names. So they start from 1, 2, 3, 4, 5, blah, 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 all the way to 299. And now I can go into Photoshop and I can open them as an image sequence. So that's the trick. Let me actually see how the last one looks like. Yeah, it's kind of more or less centered, so not that bad. So you open Photoshop. Let's see, what can I close here? Input, output, sparse matrices are here. Okay, so again, you can probably do animations in maybe some other software as well, but in Photoshop, you can do it really easily. You go File, Open, and then let's find this folder. So you click on the first one and you say here, open as image sequence. And when you do that, it will ask you for a frame rate. Maybe this 2997 is, maybe you can use that one. So it's 30 frames per second. Okay. And it just kind of, it opens it, basically opens one image, but it opens it as an image sequence. And you can then render it into a video. So let's try to do that. Should not take very long. So you can go under File, Export, Render Video, and then these are the settings that you can use. So MPEG 4, MP4, YouTube quality. I use this kind of settings for YouTube because it's just, you know, it will give us a high quality video with relatively small size. And I will just kind of, I can name it. Just grab this name. You should see. Okay, I'll just call it. Use the same name always. Here, GRE115, render, and it should not take too long. Let's see. Yeah, and it basically exports it as a video and also does the kind of compresses it, so it can be quite good quality video at the end. Okay, so and this is now the final video that came out. Let's see, it's actually 10 megabytes, so it's not really that long. Let's see how it looks like. Okay, so let's see. Let's say I have I hope you can see my Rhino. So I have a Lattice here, and I'm just gonna show you a small neat trick. So let's say I want to create an animation. I have it here already. Okay, I have actually the code already here. So let's say I want to create animation, and I want to kind of automatically run. What I would like to do, I would like to run these commands. Or so I would like to, for example, select all lines. So I can say select lines. Okay, then I want to use multipipe, which is this neat function that kind of creates sort of like kind of this sub-D kind of pipe geometry on these lines. Then I want to run all of this automatically. I can kind of set the pipe radius maybe to 0.2. Caps end off, maybe I can put it to on. And then strut divisions, maybe I want to put it to 5. Okay, and now I got the kind of sub-D geometry here. And now I want to actually maybe, do something like I want to select lines. Then I want to hide them because I don't want to see them really. And then I want to run this view capture to file. View capture to file. And then let's see, CS. Okay. View capture to file. Then I want to set this resolution automatically. Okay. And I want to put this under maybe frames or under this capture here. Save. And now if I go here under, just a minute, where was this? This was under grammars, animation, frames. Okay, so here I have a small frame. This is now 500 by 500. And I want to do all this that I did now. I want to do kind of in an automatic way. Maybe even additionally, I actually then want to sort of select select the sub-D. I want to delete it. I want to bring back the lines. So I can just show. I want to bring back the lines because now in the next iteration, I want to have, I want to change the lines and I want to do the whole process again. And I want to get an image at the end. So I want to kind of automate the whole process of creating this geometry and sort of taking a screenshot and then kind of restarting everything with different sets of lines. I can do this by using a rhinoscriptsyntax command called command. It's here. Okay, so with this rs.command, I can actually run a certain command in Rhino. I can actually show you maybe in a separate example. So maybe I do a new file here and I can say, import rhinoscriptsyntax as rs. And then I can create like a command. So maybe I can just do, there's some kind of command which I want to run. And this command is it's just a string variable. And I write like this, so I do underscore, and then I write basically a Rhino command that I want to do here. So for example, select line, okay? And then I can say rs.command, and then I can run the command here. I can just put the command as a string here, and there's something else that goes in. Echo true, I think I put it to false or something like that, yeah. Okay, so if I just run these, this will basically run this command in Rhino here. Okay, just selects all the lines. If you remember, there's again, if I can write here multipipe and then select curves to multipipe, I can basically run it also here. So I can say here multipipe, and I run this Python, and it's as if it's basically as if I would kind of just write it in the terminal here. Now the small problem is here that I have parameters that I need to give it, So first it asks me for a pipe radius, then it asks me for these kind of caps and then the number of divisions. So I can do this, I can concatenate all of these by basically writing underscore multipipe, and then I can put the first number is 0.5, that's maybe or maybe 0.2, that's the radius of the pipe. Then caps on or off, I can put on, and then the number of divisions is 5. Okay, so I kind of put a space bar in between. I say there's a command, and then these are the input parameters that will go one by one inside. But of course, I need to select the command still. Also, I need to select I currently still need to select everything, so I select the lines. And if I run now this Python file, it will basically execute everything. And I can do this a little bit smarter. So I can say, well, I don't even want to select the lines. I want to do something like, I want to run a com command that says, select line. And then I want to run that one first. and then I want to run another one that kind of does the multiply. So this line will basically select all the lines that are on the canvas. So I have to just make sure that all the lines are ones that I want to select. If you have a messy model, this will not work. So you have to find another way to select the lines. But if I run now this command, it will first select all the lines, and then it will apply this multipipe on the lines that are selected. Okay, and maybe I want to also, as you see, the lines are still selected. I can maybe run something like, okay, maybe I want to now, I want to hide these lines that I have. I just say hide here. And yeah, that's it. So I can just kind of just go back. If I run this, it will basically select the lines, create a multipipe, and it will hide the lines that were there. So the selection is not here anymore. I just have the multipipe. If I just deleted the lines that are not here, but I can say show. They will just appear. So if I run it again, it will kind of select it. And yeah, if I'm bothered a bit by this slowness, I can kind of run this again. rs.enable redraw false. Or if I run this at the beginning, now everything will run kind of the same way, but I think I will not see. I'll just see the final result if I run it. Yeah, it's kind of a bit faster. Okay, and then the last command that we can run is this, which is a bit more complicated. It's the one that kind of capture to file. And I just want to show you how to run that. It's a bit more complicated because we need to put in the path. Or so just see. Okay, so that one is the most complicated because I create a multipipe, I hide, and then I want to define capture parameters. So maybe there's at the beginning I want to import this time because I want to have custom name. So from time import time. This time will come here in seconds. It's epoch, then animation name. There's some kind of test. Path, this is the path to my local folder. And there's some kind of width and height defined. And then the whole command looks like this. So I will kind of run the command is multipipe, and then I put in this pipe radius goes in. Actually, pipe radius is yeah, okay, multipipe. I need to put in these ones. Okay, so I have capture parameters and I have these multipipe parameters. I have pipe radius, I have divisions. They all go in here. No, actually, sorry. It's not the multipipe. Sorry, this one we already did. I just have to do this capture. It's this one here. Sorry, com capture. That's the long one. Okay, I have this view capture to file. If I put this small minus here, this will make so this command, if I run view capture to file, it will give me a dialog. But if I put this small minus in front, this will make this dialog not appear. And then I can define this width, height, and then some other parameters like scale, drawing grid, and so on. At the end, there's like enter. And I can just run this command. And this will basically run the command and save everything in this path, which will come at the very end here. And we already did this before in the Lattice module, but unfortunately there I had I couldn't set the resolution because I had the order of commands wrong, but now I did it correctly, so I'll maybe also update the file there. So first needs to be command, and then the save path goes at the very end. And first we need to have all these other parameters like width, height, and so on. Save path goes at the very end. If I run this will basically do the screen capture. I just have to make sure that just before the screen capture is run, I need to re-enable the redraw. It will redraw the screen, and then the capture will be done. and the file will be saved in this folder, I think. Yeah, let's check. Okay, so if I just run it, delete this, show, and just run this command. Okay, so it's kind of very fast, and it basically saved the result here. This is a bit smaller resolution because it's 500 by 500, but I can set these to variable. Let me just change the side, maybe like this. Okay, so I can basically automate. I can, in a way, automate screenshotting. Oh, sorry, curse the pipe. Okay, I have to just. Okay, so let's do it again. I can automate screenshotting. Okay, that's now a second frame. So yeah, there's no really a rhinoscriptsyntax command for example, this multipipe, but I can kind of hack my way through it by basically calling the command. So this command, I can kind of basically, yeah, kind of automating this is called actually batch commands are kind of command macros, or so it's kind of with Python code calling the commands in the prompt here. And this, for our purposes, this will be okay. And now I will not really show you how to integrate this in a sort of full animation, but if you remember, there's the code here, this Lattice module, and here there's animate somewhere, animate, and here we kind of do basically the same thing, but we could in theory now add these extra commands like multipipe and so on. So we can basically automate how the animations are produced.